All right. Thanks very much, Jose, and the Agile TD team for putting on this amazing conference. Big round of applause for the Testing Days team. So it's an honor to be the first on stage here. I wrote the Continuous Delivery book with Dave Farley in 2010, and lots of people thought we were crazy. And the last 7 years, it's gone from being crazy to being just the way people do things, which is as much of a surprise to me as it is to everyone else. But obviously, I'm not complaining. It's great. Over the last 7 years, I've heard lots of reasons why people can't do it, and this is my summary of those reasons and why they're wrong. I've heard, continuous delivery sounds great. Great idea, won't work here. So before I start, I just want to start by describing continuous delivery and what it is, and then I'll dive into the reasons I've heard why you can't do it and my responses to those. So continuous delivery fundamentally is about making releases boring. Who in this room has to work evenings or weekends when you push a new release of your software out? Wow, okay, that's like a quarter of you. So I take that as a personal affront that I failed fundamentally. The reason that me and Dave wrote the book was because we had to do releases at evenings and weekends, and we didn't want to do that anymore. And what went into the book was all the techniques we found for fixing that problem so we didn't have to do it. And these projects were in 2005. 2004, 2005, 2006, and we found ways to fix those problems, not by doing smart things with amazing tools, because Puppet and Chef and Terraform and the cloud didn't exist in those days. We did all the things that we did basically with Bash and CVS and talking to people. And it turned out that talking to people was the most important thing. Most of the problems were poor communication between development and testing and operations, and people using different tools and not trusting each other. And most of the solutions were just getting people together and collaborating and doing process improvement work. But ultimately, we succeeded as a team fixing that problem, and we never had to do releases again. We did them during normal business hours, and it was a process that was not exciting. It just, you ran some scripts and off it went. And it wasn't using cool, exciting technology. It was just Bash and CVS. So my mission for the last 7 years has been to help other people achieve this goal. We want releases to be boring. We want changes to be able to go out at any time of day. My test for continuous delivery is, can you release to production at the push of a button while you're sitting in a bar drinking a mojito? And if you can do that, you passed. Yay. And I saw someone tweet that they'd done a pull request on the train and pushed it into production, which I thought was great. And you can absolutely do that with a modern tool chain. The only thing that she was missing was the mojito. But apart from that, it was perfect. So the ingredients I'm going to talk mainly from the software development side of things. Configuration management. You want to be able to get a new person started on your team. They should be able to check out from version control the entire system and be able to run a single command to build the software and run the automated tests, and run a single command to deploy that build to any environment they have access to. That should be a simple operation. If it takes you days or weeks to get new people up and running, that's a problem. That's a configuration management problem. You should be able to add capacity to your production system in a fully automated way by plugging in new servers, having a fully automated process that pixie boots those, installs the right version of the operating system, the right version of the middleware, configures all that stuff in an automated way, configures the router to start sending traffic to your boxes. Again, that should all be fully automated. And with tools like the cloud and Terraform, it's super easy to do that kind of stuff now. Those are amazing tools. So configuration management is part one. The next piece is continuous integration. So who in this room is practicing continuous integration on their team? Put your hand up. Keep your hands up. There's going to be a test. Unless everyone on your team is pushing, or all the developers on your team are pushing into a shared trunk or master at least once a day. If that's not true, put your hands down. If you're working on long-lived feature branches that don't get merged into a shared master at least once a day, put your hands down, otherwise keep them up. Okay, so shared trunk, everyone's pushing into a shared trunk. If when the build fails, it's not typically fixed within 10 minutes, put your hands down. Otherwise, keep them up. All right. So there's about 30 people in the room doing continuous integration. Well done. Big round of applause for those people. Continuous integration is not running Jenkins against your feature branches and then ignoring the build when it fails. It's a practice. My favorite paper on continuous integration is called Continuous Integration on $1 a Day by James Shaw. It talks about doing continuous integration with an old workstation, a rubber chicken, and a bell. So you start working on some features on your laptop, and you get done with your increment. You write a test, you make the test pass, do some refactoring, and then you're ready to share your work with everyone else, because that's what version control is for. But before you do that, you're going to walk to the old workstation in the corner of the room, and you're going to look for the rubber chicken. If the rubber chicken's not there, that means someone else is checking in, so you have to wait. And once the rubber chicken's there, you can take it, and then you're going to first merge from trunk into your, before we do that, we're going to run the build locally, even before we get the rubber chicken. Oh, I've gone way too far ahead. All right, so first of all, you run the build and test on your local machine. That passes. Then you pull from trunk and do a merge and run the build and test again, and hopefully that passes too. You do it twice so that you know if the build fails, if it was your changes or if it was the merge that broke them. So you've got to disambiguate those two cases. Once you're done with that, you've got the rubber chicken, then you're ready to push into trunk. So I'm going to push into trunk, and I'm going to run the build and test on a machine that's not my machine, because as we all know, the works on my machine certification is useless. So once we do that, hopefully the test pass again, and then I'm done. I ring the bell, ding, everyone's like, woo, go Jazz, put the rubber chicken down for the next person. If the build fails, I've got two options. I can either go back to my machine. I've got a few minutes to find the problem. Maybe I forgot to check in a file. If I can't fix the problem in a few minutes, what's my option two? Revert, that's right. It's as simple as git revert, git push. Off you go. So one of the most selfish things you can do as a developer is leave broken code on trunk. So don't do that. Everyone, I got into trouble for saying that because, obviously everyone checks in at 4:55 p.m. and then the build runs and then the build breaks. And people are saying, well, Jez, you're encouraging people to work late. And I say, no, absolutely not. Git revert, git push. I actually once worked on a team where you would just delete the code if you couldn't get it checked in by the end of the day. And then you go home, have a good night's sleep, come in the next day, and typically you can write that code again much more quickly and much better than you wrote it the previous day. I do most of my design when I'm sleeping or running or in the shower. That's where I do my best design work. So very useful to be able to get a good night's sleep, unlike last night. So that's the practice of continuous integration. And the key thing, and it's in the name, continuous integration, is that everyone is pushing into a shared trunk once a day, at least, working in small batches. So the second piece is testing. I still love this diagram from Brian Marek. And the idea is there's all kinds of tests that we're doing as a team. On the bottom left, there's unit tests, component tests. These are tests that developers write to validate that the system behaves according to their expectations. In my experience, the only way to create maintainable suites of automated unit tests is through TDD, because TDD forces you to design the system in a testable way. If you try and retrofit unit tests onto a system that wasn't designed with TDD, it becomes painful and expensive because the system's hard to test because you didn't write it test first. On the top right are the things we can't automate. Showcases, usability testing, exploratory testing, those things are all manual activities. On the top left are, everyone has different names for this. I call them functional acceptance tests, but they're typically end-to-end tests that test business processes all the way through. So entire business processes all the way through, user journeys. And again, that stuff should all be automated. And this stuff on the left forms your regression suite. And the reason it's automated is because there's no way otherwise to speed up the release process. It just takes too long and it's too error-prone to do it manually all the time. One of my colleagues, Neil Ford, has a joke that when humans do the things that computers could do instead, all the computers get together late at night and laugh at us. And nowhere is that more true than if you have humans doing regression testing. It's a terrible waste of human talent. And then on the bottom right are the things, some of which are manual, some of which are automated, capacity testing, security testing, performance testing. The crucial thing is you want to be doing those things all the time from the beginning of the project. That's testing the architecture of your project. The architecture is, according to Martin Fowler, the stuff that's hard to change. If you find out there's a problem with your performance at the end of the project, you're in big trouble. You want to test that stuff from the beginning of the project so you can validate your architectural assumptions. Now, there's been a lot of controversy in the testing community about automated testing. And James Bark, among other people, has suggested talking about automated checks instead. I think it's a losing game to try and redefine existing terms. But I think the underlying issue is a real one. And I just want to be very clear about this. Continuous delivery is not about getting rid of testers. Testers serve a vital and essential role in the software delivery process. It is not to do manual regression testing. The job of testers is to help the team understand the quality of the system so they can make decisions about it, to do exploratory testing, to create feedback loops from that testing to acceptance tests to unit tests, to help to build and maintain the suites of automated tests working with developers. That doesn't require that testers need to know about programming at all. I've seen very successful teams where testers who aren't programmers pair with programmers and create automated tests and maintain them together. I think that's the best way to create and maintain automated tests. So yeah, I just want to make that clear because there's a lot of crap going around. Continuous delivery means no more testers or everyone has to learn test automation. I don't think that's true at all. So what do we do once we've got all these tests? We create what's called a deployment pipeline. This is the key pattern in continuous delivery. The idea is you should be able to reproduce the state of your production system, everything except the data, which should be in a database of some kind. All that state should be reproducible from version control. I should be able to run a script and be able to create test environments, staging environments, my production environment on demand in a fully automated way from information in version control and scripts in version control. And the application as well. Anytime I make a change to the application, that's going to trigger the automated unit tests. Those should run in a few minutes. If they break, no one checks in unless they're fixing it. Once you fix the unit test, that triggers longer running automated acceptance tests, which you run in parallel. Those should complete in the order of tens of minutes. If those break, someone should be working on fixing those. You don't stop people checking in, but someone's working on fixing those as their highest priority. Once we have all the automated tests running, then we can go downstream to more long-running tests, performance tests, exploratory testing, usability testing. Those tests take much more time and resources. They're expensive, so we don't want to run them against builds unless those builds are known to be reasonably good because they've passed all the automated tests. What we're doing is trading off fast feedback versus comprehensive feedback. And then we should be able to self-service good builds to staging and production environments in a push-button way. So that's the goal. Your process will be much more complex than this. This is a very simple linear process. But the idea is you can trace every change through the builds and the environments and the tests that it's been in all the way to production and have high confidence if a build has gone through this process that it's releasable. So that's my TLDR continuous delivery. I have a website, continuousdelivery.com. All this stuff is available, Creative Commons on that website, so you can go and check that out. It won't work here because. So these are the main reasons I've heard why continuous delivery is not possible. We're regulated, we're not building websites, too much legacy, and my personal unfavorite, and I have really heard this in real life more than once, are people are too stupid. People are too stupid. So these aren't the actual reasons. The actual reasons are our culture sucks or our architecture sucks. And so I'm going to go through these things and explain why it's actually these things and then talk about these things. So we're regulated. I like to show people who complain about being regulated this slide. Who's seen this slide? Okay, a bunch of you. Not enough of you, my goodness. So this is from 2011, from a talk at Velocity. This is Amazon's production environment. They're making changes to production every 11.6 seconds, up to 1,079 deployments per hour. On average, 10,000 boxes receiving those deployments, up to 30,000 boxes receiving those deployments. They're about an order of magnitude faster now, 6 years later. And they keep getting faster even as they keep getting bigger, which is one of the signs that they've got an architecture that enables continuous delivery. So I'd like to point out that Amazon is a publicly traded company, which means they have to follow Sarbanes-Oxley, and they process the occasional credit card transaction, which means they have to follow PCI DSS. So they are, in fact, heavily regulated. I also like to point out that this was extremely painful and expensive for Amazon to do. They spent 4 years re-architecting their production environment to allow them to do this. So this was non-trivial. I'll talk a little bit about that if I have time later. Last year in 2016, when the USA was not being run by a madman, I was working in the US federal government for an organization called the General Services Administration in a team called 18F. One of the things I did when I was working at 18F was work on a team that built a platform as a service called cloud.gov. And the first cool thing about working on that team was that we were able to get the domain cloud.gov. When we saw that was open, we were like, that's amazing, book that immediately. And there's a little server that sits somewhere in a room which manages all the DNS for the government. So we went down there and sorted that out. And we built this platform as a service. So it uses Amazon Web Services. There's a special region of Amazon Web Services called GovCloud, which is staffed by US persons, which only US government agencies can use. So we deployed open source Cloud Foundry on top of Amazon Web Services and built a bunch of stuff around it to produce cloud.gov. The reason we did that was not because the cloud's trendy or we wanted to save costs, even though those things are true. The reason we did it is because of this sheer amount of regulation that you have to follow when you're building services in the government. So to launch a moderate impact system in the US federal government, you have to implement and document and test and document the testing of 325 information security controls. That typically takes between 6 to 12 months after dev complete before you can launch the service. So what we found is that most of these controls are operational controls. They're things like having backup power in your data center, having fire extinguishers in your data center, all the way through to controls around change management and all the stuff that you expect. Now, some of those controls are implemented by Amazon, and there's a program called FedRAMP which allows you to get your control implementations signed off by the CIOs of the Department of Homeland Security, Department of Defense, Department of the General Services Administration, and you get a certificate, and then other agencies can use your cloud platform. So Amazon Web Services has implemented and got this certification for a bunch of these controls. What we did is built a platform as a service on top of it using Cloud Foundry, where we implemented a lot more of the controls. And so by the time we got done with that, it took us about a year to build the first version of that. And then it took us about another 9 months to go through the certification process. But at the end of it, of those 325 security controls, 269 were handled by cloud.gov, which meant that if you're deploying an application on top of cloud.gov, you only have to worry about between 15 and 56 of those controls. So that substantially reduced the time it took to go from dev complete to live in this very heavily regulated organizations in the US federal government. And that's something you can do in days or weeks. You have templates for all those controls, and we actually have this program called Open Control. It's an open source community to do TDD for control implementations and create documentation automatically, which is kind of exciting stuff, I think. So that substantially reduced the time it takes to go live. Cloud.gov itself, all changes are made to that through deployment pipelines using continuous integration from source in GitHub. You can actually go and download, it's all open source, so you can go and download cloud.gov, go to github/18f/cg provision, all the source code's there. You can stand up your own instance of cloud.gov. It's all done using continuous deployment. We make changes to that environment multiple times a day using continuous delivery. So one of the reasons that I did that is so that I could say, we're doing this in the US federal government. What's your excuse? So that's the most heavily regulated environment I've ever worked in. People are so careful because, frankly, they don't want to end up on the front of the Washington Post. And we were able to do this stuff there. I mean, it's an amazing team of about 15 people who built this thing in a year. One of the most talented teams I've ever worked on. but it's entirely possible to do it. A lot of the reason people say you can't do this in regulated environments is change management. So one of the other things I've been working on is doing research into what predicts IT performance, the practices that predict IT performance. And we actually, we have about 20,000 data points from thousands of teams worldwide in all kinds of organizations of all sizes. And one of the things we wanted to look at is, does change management work? So we asked people whether they have some kind of change advisory board or change approval board or some kind of process where some other team has to approve your changes versus no change approval process or peer review. What we found is that that doesn't work. Change advisory board substantially reduces throughput. It makes it much slower to get changes out. It's completely uncorrelated with time to restore service and the failure rate of your changes, the percentage of your changes that either fail or have to be rolled back. So having an external body approve your changes doesn't work. It just makes things slower. Having a peer review process is more effective, and having no change approval process is actually more effective. So our research shows that that reason why you can't do CD in regulated environments doesn't work at all. What does work, it turns out, is having a deployment pipeline, where you can see every change to the system, what tests have been run against it, what environments it's been in, who approved those deployments, what scripts were run, the output of those scripts, timestamps for all that stuff. Auditors love that stuff. It's much better than a piece of paper that says that someone may or may not have done something with all the boxes ticked. And as we know, the only reason that you have that is so that if something goes wrong, you can say, look, I ticked all the boxes, so it's not my fault. Most change management is what I like to call change management theater. It's not actually about making things better. It's just about covering your ass when things go wrong. And there's a much better way to do it. Continuous delivery is actually more important when you have a regulated environment. So we're not building websites. My favorite case study of continuous delivery is actually from firmware. And the reason I like it is because people don't update their firmware 10 times a day. In fact, who has updated their firmware in this room? On their printer? Okay, a few cautious souls, excellent. But it's not something that people ever thinking about doing in many cases, or if you do, it's not something you do very often, hopefully. So 2008, they had a problem, which is that the firmware team was on the critical path for all new ranges of printers and scanners that the LaserJet organization was releasing. And they tried, I mean, this was true for years that the firmware was the critical path for new products. And they tried hiring people, firing people, insourcing, outsourcing, all the usual things. And in the end, they were so desperate, they went to the engineering management to get help, which is how you know things are really bad. And the engineering management did something interesting. Normally, when you want to find out what's going on with your money, people do cost accounting. They look at the things, they see how much they cost, and then they get rid of the expensive things. What are the expensive things in software development? People. So we all know where that ends up. So what the engineering management team did instead was something called activity accounting. They looked at what activities the budget was being spent on. What they found, 10% of the budget spent on code integration, 20% of the budget spent on detailed planning, as the engineers fought with the product people to explain why they were so slow in excruciating detail, estimating all these stories. 20% of the budget was spent supporting that detailed estimation. 25% of their budget was spent porting code. Every time they released a new range of devices, they'd take a branch in version control. Anytime you have a bug or a feature which has to work on multiple different products, they have to port that code across the branches. That's taking 25% of their budget. 25% of their budget is spent on product support. What does that tell us? Yeah, it's a quality problem, right? Nice proxy variable for quality. 50% of their budget is spent on manual testing. You subtract that from 100%, what you're left with is 5% of your budget to spend on actually building features. Now, who's works in an organization where you've said, we'd love to do some test automation, we want to do some refactoring, and the manager says, we'd love to support you doing that, but we can't because we haven't got time. Get on with building the features. Right. And the flaw in that argument becomes really obvious when you see the information presented in this way, because the reason you're going so slowly is because of all this non-value add work that's consuming all your time and budget. And the only way to ever get out of that mess is to actually address that. So what they decided to do, and also they had some cycle time metrics, took a week to get changes into trunk, 1 or 2 builds a day coming out of trunk, 6 weeks for a full manual regression. So they did something crazy that I don't really recommend, but it worked for them. And why it worked, it's too long to go into here, but there's a book that you can read about it, which is great. They re-architected the entire system from scratch. They came to an agreement with the hardware people so that there would be one hardware platform for all the different ranges of devices. So they only had to target one hardware platform. That meant they could build one package that ran on all the different devices. There was still variation. The variation between devices was handled by using configuration options, or feature toggles, as we call them today, to make them sound trendy. So the system boots, looks at the hardware profile, gets an XML file, and says, oh, this is a scanner, so we'll turn off these features, or it's a printer, so we'll turn on these features. So in this way, we can create a single package that runs on everything. That allowed them to implement continuous integration. In order to make that work, they had to implement an awful lot of automated tests. And in order to make those automated tests work on developer workstations, they built a simulator for the target hardware platform, which was a substantial engineering effort. There's very complex ASICs on those boards. The simulator was really a lot of work to build, but then developers can reproduce test failures on their workstations, which is hugely important. So this is not what they started with. They started with a continuous integration, and the build was breaking all the time. And in order to make it so the build wasn't breaking all the time, they ended up after 2 years of work and process improvement with this system. So this is the result of 2 years of messing around before the continuous delivery book came out. They independently invented continuous delivery. So 400 engineers working on a 10 million line code base. Every engineer has their own Git repo they push to. When they push to their Git repo, they had this build system which would pick up the change and run about 2 hours of automated tests against just that change. If it passes, it gets promoted to stage 2. Stage 2 is always running. It picks up all the changes that have passed stage 1, does a merge, runs 2 hours of automated tests against those merged changes. If that fails, you get an email. Here's the merge conflict, or here's the test failures. Here's the stack traces, and then developers can reproduce that and fix them on their development workstations. Once that passes, then your code gets pushed into trunk. That's the only way you can get your code into trunk, is by having it go through these stages. And what that does is it forces developers to work into small batches, because you are much more likely to get your code into trunk if you submit an hour's worth of code than if you submit 3 days' worth of code. Because if you submit 3 days' worth of code, the merge conflicts are going to be a total nightmare to resolve. So it encourages developers to work in small batches, because that's the only way they can get it done, so they can get their story points. And then level 2 is 2 hours of automated tests that works on a simulator. Level 3 is another 2 hours of automated tests, different tests, that work on emulators, on actual physical logic boards. And then if that works, you get promoted to level 4, which is a complete regression suite, about 30,000 hours of automated tests that run overnight. So developers can get feedback if they took their software away from releasable within 24 hours, and they can fix it straight away. So 400 developers, able to get about 100 changes into trunk a day, about 100,000 lines of code change a day into this 10 million line code base, getting about 10 to 15 good builds a day out of trunk, working on this system, completely gets rid of the manual regression phase. And it also changes the economics of the software delivery process. 10% code integration. They're now spending 2% of their budget on continuous integration. They came to an agreement with the product people. We'll get off the critical path. They had 2 goals with the re-architecture. Number 1, get off the critical path. Number 2, they were aiming for a 10x productivity improvement, where they were measuring productivity in terms of the percentage of the engineering budget spent on innovation. So that was their productivity measure. So they basically got rid of detailed planning and did very high-level planning instead. They weren't porting code anymore. They were spending some engineering budget maintaining that branch. Product support goes down from 25% of budget to 10% of budget. What does that tell us? Correct, quality improvement. Most of the testing was automated. Innovation goes from 5% of the budget to 40%. So that's an 8x improvement in productivity. Not 10x, still pretty good. Any mathematicians in the audience notice something wrong with the right-hand side? That's right, it doesn't add up to 100%. That's because there's a new activity. They are spending 23% of their engineering budget building and maintaining the automated tests. What would happen if you went to your manager and said, please can we have 23% of our engineering budget to spend on test automation. And yet, they're doing that, and they're 8x more productive than they were before. And this is the slide to show your CFO. Overall development costs reduced by 40%. Programs under development increased by 140%. Development costs per program down 78%. Resources now driving innovation increased by 8x. So costs go down, quality goes up, time to market goes down, and we're not deploying 10 times a day, we're building firmware. Continuous delivery is not just about making releases boring, although that was why we did it in the first place. The reason it's popular is because it has all these side effects, if you like, on the software development process and the economics of that process, and it makes it cheaper and faster and higher quality. So the third reason people say we can't do continuous delivery is legacy. So I'm going to show you a video from Suncorp. Suncorp is Australia's biggest insurance company. They had at one point, I think about 18 different mainframe platforms that they'd got through acquiring a bunch of different insurance companies, and they wanted to consolidate them, but in order to do that, they needed to know that they weren't breaking stuff. So I'm going to show you a video from a friend of mine, John Cordyback, who was a consultant working there. He still is at ThoughtWorks, showing the automated test suite they built to run against those mainframe systems.
So you're going to see a little test running here. I'm going to run that, and what you're going to see here is a demo. There's a couple little mistakes in it, but that's okay. The green screens are remarkably durable and remarkably quick, and I found this to be an incredibly good testable endpoint. So they're kicking off a little test here, and this is actually going through an amazing number of workflows. This is creating a new company. This is and creating new contracts for that company. That generally takes an analyst about 10 minutes to do, 15 minutes to do. And what we discovered through this was that green screens are amazingly fast and amazingly durable, not just the systems themselves, but testing them is very fast. So what's going on the bottom is jobs are running, and they're waiting for the jobs to run, and then they're kicking off batch jobs to run in the background, which is quite remarkable. So what we were doing was, for supporting UAT testing, because we had this type of capability, we could set up 500 to 1,000 policies anytime we wanted for UAT to run. We could set up training environments with thousands and thousands of policies for people to learn from. But what we found, and we use Concordian, so I'm going to stop it right there. This is just an example of some of the Concordian output. But I was very surprised that GUI test works so well on a mainframe environment. We didn't think it would, but we put a lot of time into the test engineering and working with the system to make.
So there you go, using Concordian and then using a little shim to drive the mainframe through VT, they were able to produce these very comprehensive test suites, which substantially reduced the pain and complexity of making changes and substantially increased the confidence of the release managers making releases, because they knew when they released that they'd tested all this stuff. So you can absolutely do this stuff with mainframes. However, architecture is important. One of the other things we've looked at for the last 4 years of the State of DevOps report is the importance of architecture. Based on our data, architecture is the most important factor that predicts your ability to do continuous delivery. When people say, architecture of continuous delivery, people normally, their minds go to microservices, Kubernetes, Docker. I want to point out, I have nothing against those tools. Those are great tools. That's not the critical factor. You can do this stuff on mainframes. What we found with the critical factors is whether teams could answer these questions. Can I make large-scale changes to the design of the system without the permission of someone outside the team or depending on other teams? Can my team complete its work without needing fine-grained communication and coordination with people outside the team? Can my team deploy and release its product or service on demand independently of other products or services that I depend upon? In other words, do I need to do big orchestrated deployments because everything has to go out in lockstep because it's tightly coupled, and oh my God, what a nightmare? Or can I push out my service independently without breaking everything else? Can I do most of my testing on demand without requiring an integrated test environment? Can developers run tests on their workstations and get high level of confidence that their service or component is releasable? And can I perform deployments during normal business hours and negligible downtime? So it turns out being able to answer yes to these questions is really, really important. You can do that with mainframes. You can rebuild your entire system in microservices with Kubernetes and not be able to answer these questions yes. If you do that, you just wasted all your money. Kubernetes, Docker, microservices, these are great things, but you've got to do it right. Otherwise, there's no point. It's the outcomes that those tools enable, not implementing the tools, that's important. So I'm going to skip ahead. And I should just say, one thing I want to emphasize is I don't actually recommend doing big bang rewrites. Anyone seen Tomb Raider? Okay, I haven't. But I have been to these temples in Cambodia. What happened here is a tree grew on a temple, and then a bird came and did a poo on the tree, and in the poo was a seed, and from the seed grew a strangler fig, which grew up around the tree and strangled it, and the tree's dead, and all that's left is the strangler fig. So that's a metaphor for what you should be doing with your architecture, which is gradually over time evolving it and using evolutionary approaches so that you can make incremental architectural change over time. There's an article by Martin Fowler on strangler application. This is what Amazon did. Don't do big bang rewrites, gradually implement new stuff. Finally, I want to talk about this one. Our people are too stupid. Our people are too stupid. So I've got a little story about this. Adrian Cockcroft, who ran cloud at Netflix, he was their cloud architect. He would go and visit other companies, and the CIOs would ask Adrian, where do you get your amazing people from at Netflix? And he would turn around to them and say, I get them from you. And his point was not that he was hiring the brilliant people. His point was that Netflix had built an organization and a management structure and leadership that enabled people to do their best and create outcomes effectively. And that's what's important, the system. If you hire good people into a bad system, you break the people. Deming says a bad system will beat a good person every time. People don't create outcomes. Teams create outcomes. And what enables teams to work effectively is good management and good leadership. My favorite story about organizational change comes from a company called Numi. So Numi was a joint venture between General Motors and Toyota in Fremont, which is 30 minutes from where I live in California. In 1980, this auto manufacturing plant in California was the worst performing plant in the whole of General Motors North America. The workers were so mad that they were, mad as in angry and dissatisfied. They would sabotage the cars by putting Coke bottles in the doors so they rattled. They would take drugs and drink and gamble on the job. There was a 20% absenteeism rate. And this factory was so bad that GM shut the factory down and fired everyone. At around the same time, General Motors and Toyota created a joint partnership, and something crazy happened. GM's union leadership convinced Toyota to rehire the same people to work at their new joint venture in the Fremont factory. And they sent those people to Nagoya in Japan, to Toyota City, to work on the Toyota production line and learn the Toyota production system. And they then came back and started working at Fremont, and within a few months, they were producing the highest quality cars of any GM factory in North America, and as high quality Toyota Corollas as Toyota was producing in Japan. Same people. Wasn't the people that were the problem. It was the management. So what's different? Well, here's what a production line looks like. This is Toyota UK factory. So let me tell you what happens in a General Motors factory. General Motors factory, what happens is, car comes along, you've got a job, right? So your job, maybe you've got to bolt a seat in. So car's coming on the production line, start bolting in the seat, the threads breaks on the bolt, you've got to pull it out, you've got to put in a new bolt, but before you can get that done, you run out of space and the car goes on down the production line. What happens? Nothing. That car goes off down the production line. At the end, you've got QA, which looks at it and says, no one can drive that. It's got no there's no seat in it. Off it goes to a parking lot to rust until maybe someone fixes it. Another car comes along. No one's driving that. The engine's in the wrong way around. Off it goes to a parking lot. Along comes another car. That one looks all right. Let's send it to a dealership and see what happens. So, QA, driven quality process. What happens in a Toyota factory? Well, car comes along, same deal. You're trying to put the seat in, nut the bolt threads, you pull it out. And once you get about 2/3 away through your space, if you're not done, there's this thing you can pull called an and-on cord, or new factories have an and-on button. You press that, a light goes on, a jolly little tune plays, do-do-do-do-do, and a manager comes, and then the manager helps you. How good is that? And then you and the manager work together to get that problem fixed. If you can't get it done before you run out of time, then you can pull the cord again, another light comes on, another jolly little tune plays, do-do-do-do-do, and the whole production line stops. Then you fix the problem, start the production line up again, off goes the car, and you reflect sometime later on how you could improve the process. And there's a whole army of people who will help you. Maybe you're like, well, this tool would be much better if there was an angle in it here, then we could get it in more easily, and they'll go and build that for you. You can actually improve your work process. And so that thing about building quality in and giving the people doing the work the tools and the ability to build quality in turns out is what's important. So, our people are too stupid. Turns out that's true, it's just not the people you were thinking of. So, John Shook, who created the training program for those NUMMI workers, has a great article in MIT Sloan Management Review. And you can read this story. So, This American Life is a podcast, a really good podcast. The NUMMI story is on This American Life. There's a transcript as well. I really recommend it. There's an article in Sloan Management Review by John Shook, who designed the training program, about what they did to change the culture. And he says, what my experience taught me that was so powerful was that the way to change culture is not to first change how people think, but instead to start by changing how people behave and what they do. Now, they totally failed to reproduce what they'd done in the NUMMI factory in GM North America. It took them 20 years to take those lessons and spread them through the rest of North America, by which time GM had gone bust. All those people in the NUMMI factory, that's where the term lean comes from, those people in that NUMMI factory who then went and wrote papers and books and gave talks. They invented the term lean, that's where it comes from. And people from other plants would come and take pictures of the NUMMI plant, and they'd have the and-on cords, but nothing would change. Because the managers were rewarded based on how many cars came off the production line, whether or not they worked. So if you pull the and-on cords, a manager would come, but they might not give you the help you were looking for. So we have this problem in software methodologies where, a methodology basically is a bunch of stuff that works in one organization, and then we copy it and do the same stuff, and we think that it'll achieve the same results. I think that's misguided. Taking things that worked in one complex system in pursuit of a particular set of goals and copying it does not guarantee you'll achieve the same results, partly because it's a different system, and also partly because hopefully you have different goals. You've got to work it out for yourself. And the failures that you'll encounter while you're working it out for yourself are important. There's an early story from Toyota when they were building looms back in the 20s and 30s of the last century. Someone stole the plans to their looms, and Kiichiro Toyoda, because that's the family name, was asked what he thought about people stealing the looms. And he said, certainly the thieves may be able to follow the design plans and produce a loom, but we're modifying and improving our looms every day. So by the time the thieves have produced a loom from the plans they stole, we will already have advanced well beyond that point. And because they do not have the expertise gained from the failures it took to produce the original, they'll waste a great deal more time than us as they move to improve their loom. We need not be concerned about what happened. We need only continue, as always, making our improvements. That's how you implement continuous delivery. That's how you get better at what you do. Don't copy what other people did. That's a useful inspiration, but it's not going to create a culture of improvement at your organization. You have to do that yourself, and management has to focus on helping you do that. So I just want to end a couple of things. How do you get started? Firstly, agree and communicate measurable business goals. People say to me, I want to do continuous delivery or DevOps or whatever, and I say, why? What's the measurable business goals you're trying to achieve by doing that? I should be able to go to anyone in the organization and ask them why they're doing what they're doing, and they should be able to tell me the measurable business organizational, customer goal that they're working towards by doing that work. That's one of the most important jobs of leadership, to agree on and communicate those goals. You've got to give teams support, time, and resources to experiment, to work out how to get better, because you can't just copy what other people do, you have to work it out for yourself. Most of what I learned from continuous delivery and DevOps is talking to other people, especially the people you're afraid of talking to. One of my most important CD hacks is go and find the team that is really pissing you off and go and buy them lunch. Ask them why they're mad and spend an hour listening to them and then find some way to help them. I was talking to Gita the other day. You should go and talk to her about this. She has great ideas about how to do this stuff. The talking and the listening in particular is the most important piece. It's going to take you a long time to do this. Find ways to achieve quick wins and then share those learnings with other people and then keep going. And finally, a word from Rear Admiral Grace Hopper. If it's a good idea, go ahead and do it. It's much easier to apologize than it is to get permission. Thanks very much for your time.
Wow. Thanks so much. Thanks so much. So, questions? May I? Oh, fuck. The glasses. Oh, my God. Oh, my God. You cannot dive anymore.
Hi. I was curious about the security testing you put in the quadrants.
Yeah.
What do you... If there's an application that you need a second party to check your software, if it is vulnerable for any, whatever, cross-site scripting and all these kind of things, what do you do with it? So we actually researched this in the State of DevOps report. If you want to get the State of DevOps report and my slides and a bunch of other stuff, send an email to jezhumble@sendyourslides.com with the subject DevOps. You can get all this stuff, and we talk about exactly this question in the State of DevOps report, or go to devops-research.com. What we find is that shift left applies to security as well. You should go and see Angie Jones' talk later on. You probably have no choice because it's a keynote, but it'll be great. She's talking about exactly these things. So you build it in. So that means developers are responsible for security, which they don't like, but they've got to suck it up. And so you've got to build things like vulnerability testing. You can have OWASP ZAP run as part of your pipeline. You can do checks for buffer overruns, common vulnerabilities like the OWASP top 10. There's checks for a bunch of that stuff that you can build into your deployment pipeline. You should do that. And then you have security professionals helping your team do that work themselves. The crucial thing is you don't want it to be a downstream phase that happens after dev complete. As with all testing, you want it to be done as part of the delivery process. So that's the short answer. And what happens with the tests? Because you have this top 10, but there's always a part of this creative new things that we didn't thought about how you can hack your website. How do you test that?
Yeah, so this is true. And again, this is where continuous delivery will help you. Experian was the biggest hack this year, and the Experian hack happened because there was a vulnerability that was discovered in struts, and it took them a month to patch it, and within 3 days after that vulnerability was announced, there was people hacking the website. So it's crucial, once a vulnerability is discovered, to be able to patch it and update your systems. And in order to do that, you've got to know which of your systems have old versions of struts. How do we even work that out? How do we patch them? Well, if you have really good configuration management, you should be able to do that in a fully automated way. You should be able to say, okay, this version of struts is being used by these 10 systems. I'm going to download the new one, check it into version control, or update my dependency configuration. It's going to pull down the new version, build all those things, run them through the deployment pipeline, push a button, deploy them into production. So the crucial thing is how quickly can we get changes out there in a way that is reliable and repeatable and low risk. So it's the same capability that enables you to be secure.
More questions? More questions? Okay. Thanks so much. We have a small present for you.
Oh, yay. Thanks very much.
That's great.